Hello, so this is Electric Power Systems and we are looking into an exam from 2019 and this is the problem 2 from that exam, and it's counting overall 15%, and what we are looking into is a star connected symmetrical load that is connected to a line-to-line voltage source. And we have come to the question C, which is to calculate the power factor cosine phi. And sometimes you will calculate this and get it denoted as cosine phi. Other terms that are used are cosine theta. It goes into the same category, so we are looking at power factor, but it's just a Greek letter that is varying. The only thing that is important when you're solving the questions is that you are true to the convention and that you are true to the letter that you chose for the power factor. So what is the power factor? The power factor is the efficiency of the system that we are looking at. So that means that how much of the power that is coming into the system is coming out of the system, and it's modulated by this impedance, because the impedance is what determines the ratio between the active and reactive power in the circuit. And we have computed these impedances, so we are known to that. We have that from the question A, the impedance, and we also looked into the line currents. And the reason why we chose the line current R to be the phase of reference is because then we will immediately get the power factor with the angle that is in between the voltage and the line current. And when we take the cosine of that value, we will then get the ratio. Because it's really explaining how is this impedance managing to deviate the composition that is made from the line current to the phase voltage. And if you look into the impedance triangle, you will see that this amount of Q that in relation to P that will govern it. And in this instance, we then see that when the voltage is at phase 0, the line current is lagging that voltage by 61.61 degree. And that is known because we have the impedance. And another information from this impedance is that it's a positive impedance, which means that the circuit is in its natural state an inductive circuit, and it will then lag the voltage. We can also derive the power factor from this impedance alone by studying the complex number. This will give us two different values. We have the modulus, which is simply applying Pythagoras, and then we will get the absolute value of this complex number, and then we can also get the argument set. And it's all related here in the impedance triangle. So here we take the square of the resistive element and the square of the reactance, and we take the square root of the sum of those two values, and we will get this quantity, which in this instance is 43.29. But what we are really interested in is this argument to set, because that tells us the relation, because it tells us the angle which is in between P and Z, and that is governed by the ratio of Q over P. So we take the tangents inverse to Q over P, which is the tangents inverse of 38.9, which is here, to 20.58, and we will get out the same value that we have here, 61.61, which is the same that the line current is lagging the voltage. And then we can simply take that into the cosine phi, and we will take cosine to 61.61, and we will get the ratio, which is here 0.471, and that's the answer to the exam question from 2019 and the task to C.